Yes.
Is K just a constant?
K is,
If we're finding K, is it a constant?
yeah, it's usually a constant for each wave, right? It is the wave number, which is, it is just 2 pi divided by the wavelength, right?
Oh.
Which the wavelength is just this distance, which is kind of fixed, right?
Oh, okay.
Yeah, it's just the distance between two peaks.
Okay.
So K is just, yeah, constant.
So the T is definitely 0. What is that though? T is
Sure.
How do I find V? How do I even find V?
Your question is how do you use amplitude to find V? I mean, the easiest way I could see here, maybe there is a better way, is to use V equals F lambda. F is a frequency, and lambda is a wavelength, but maybe there is a way to involve amplitude into this, but that's beyond me. Yeah, so lambda is a wavelength, so it is like right here. Yeah, let's try like 2 more minutes and then we can keep going.
I can only find like the angular frequency. I don't know how to get the rest.
You mean the rest meaning part B or you mean the rest of part A?
A.
Oh, okay.
Just A.
So I mean K is just 2 pi over wavelength, right? You mean you don't get the numerical answer right, or you just not sure how to do it?
I'm just not sure how to do it.
Okay. Do you think it's a good idea if I work it out, or should we? Yes. Okay.
Yes, please.
Okay. So maybe temporarily just using this. So 2 pi over lambda, right? The lambda is a wavelength, and that is 40.0 centimeters, right? So your K would be 2 pi. Converting this to meters, right? You have 0.400 meters, right? That's 2 pi times, that's pi times 5 essentially, right? 2 pi times 5 divided by 2. Well, anyway, numerically, it will be pi times 5, 3.14, 14,570, 15.7 radians per meter, right? And then The next thing is the period, right? The period t is just 1 over the frequency, right? The frequency is given somewhere there, 8 hertz, right? So it is 1 over 8 hertz. Hertz is the convert of a second, right? So that's pretty straightforward. 1 over 8 is 0.125 second, right? And then angular frequency, omega, is 2 pi f, right? Well, it's 2 pi times 8 hertz, 16 pi, right? And that is gonna be, yeah, whatever is written down there, because this is a bit much to multiply pi. And the last thing is the speed, right? Speed is just lambda times f. And lambda is 40 centimeters, so it's just 8 hertz times 0.400 meters, right? And that's gonna be 3.20 meters per second, right? Because this is 1 over second. Now, what else do we need to do? Okay, so for the phase constant, right? This is a little more involved. So we just look at the expression. We know that the pen is dead. So let's do a new pen. We know that y00 is 15.0 centimeters. And we are also given that A is 15.0 centimeters, right? So that means, and we also saw earlier that this is just A cosine of phi. Phi is the initial phase, right? Because x is 0, t is 0. Then it follows that cosine of phi is 1, right? Wait, no. I think we use the sine here, right? Not the cosine. We use the sine. So if we use the sine, then psi phi equals 1, meaning that phi is pi over 2 radians. Right? And then finally, we now know everything, right? We know that A is 15. We know that K, the wave number, is 2 pi over 40 centimeter is this number, right? And we know that omega is this, and we know that phi is pi over 2. We put everything together, we get that yxt is 15.0 A, right? Sine kx minus omega t plus phi, right? And then we can already see that phi is pi over 2, right? And now with this we can just convert it to cosine if we want, right? So that's no big deal, right? So this will become just 15 times cosine of negative of this, which is the same as the cosine of that thing. So that is this, right? Using the fact that cosine of x is equal to sine of pi over 2 minus x, right? So that's so basically, when we see the problem, we can see that we have to identify A as the amplitude, right? And lambda as the wavelength, right? That's what we are given, and f as the frequency, right? And this is 40.0 centimeters, and this is 8.00 hertz, right?